Hello, everyone. It's so wonderful to be here and see so many Armenian women participating in this conference. This is extremely important, not just for the individuals that are here, but for our country and for developing what Armenia could actually become, realizing the potential of our country. And thank you for having me here. By the way, my name, pronounced in Armenian, is Rev Lebaredian. It's misspelled in English and then got mistransliterated into Armenian when I became a citizen years ago. But it's pronounced Lebaredian, just so you know. All right. Many of you probably have heard of NVIDIA. And that's, by the way, how it's also pronounced, NVIDIA. Many of you probably know it as a chip maker who creates special chips that allow us to play video games. We've been doing that for 30 years now. Some of you might know it as a way to do crypto. More recently, you might have heard of NVIDIA because we became the most recent company to be worth over $1 trillion. And that's because of all of the work we've been doing, all of the trailblazing we've been doing in innovation in artificial intelligence for the past decade. But still, I think most of you, even if you've heard of NVIDIA, you don't really know what we do and what it is that makes NVIDIA worth $1 trillion. Why are we in this position? I joined NVIDIA about 21 years ago, but NVIDIA started 30 years ago. It was a dream that was created by our founder and two other founders together, our founder and CEO, Jensen Huang. The original idea was to build a new kind of computer that can potentially make things that are out of reach and impossible today, possible. The types of processors we were building at that time, and still do today, CPUs, are general purpose computers that are designed to solve any problem. The issue is that there are some problems that require so much computation that it will take decades before we have the types of computers we need to solve them. The first such problem we chose to address was rendering for computer graphics, taking 3D worlds and turning them into images so fast that you can interact with them. And this sparked the PC gaming revolution in the 90s. So we started by building a processor that could do this. We chose this problem because it's an endless problem, one that no matter how much energy we put into it, how much work, how much innovation, it's still never quite solved. We can always do bigger and better, more awesome worlds. Around the time I joined, 21 years ago, NVIDIA went through a transition. We went from primarily being about simulating how the physics of light and matter interact with each other to produce these images into a more general purpose computing environment. We created what was called CUDA, a platform that let us take the supercomputing capabilities in our chips and leverage that for many types of problems. This started being applied to supercomputing, high performance computing, to do scientific simulations where we can simulate general physics, not just the physics of light and matter, but the fluid dynamics to predict weather, to do molecular dynamics so that we can create new pharmaceuticals and so on. About 10 years ago, 11 years ago or so, the same platform that we had built for video games that were then being used for scientific computing, some grad student at the University of Toronto discovered that they can use this computer combined with the amount of data now available to us on the internet to take an old idea, neural networks, one that was originated in the 40s and 50s, combine these things together and sparked the AI revolution that we're in today. And so this sparked the next generation of NVIDIA, the next version. This is where we create artificial intelligence, another way of saying simulating intelligence. So at heart, we are a simulation company. We started with simulating the physics of light and matter. We progressed to simulating all kinds of physics, all the other things in the physical world, to simulating intelligence. Essentially, we now have the ingredients to simulate all things that we see around us. And this poses some great opportunities, some amazing superpowers. Okay. Here you can see an architecture slide. This is the architecture of our company. Now, you may know us as a chip company, but actually our company has always been much more than that. At the bottom layer here are the chips. We started with creating graphics processors for graphics purposes. Now they're just called GPUs, and they do a lot more than graphics. They do everything from AI to physics simulation. But we also create many different other kinds of accelerators and processors. We pioneered a form of computing called accelerated computing. On top of that layer with the chips, we also build systems. We build computers that are as small as the embedded systems we put inside robots, to computers that are embedded inside self-driving cars, to gaming PCs and professional workstations, all the way up to supercomputers that are the largest computers in the world, solving the hardest scientific problems. On top of the systems layer, we have a very important software layer, the system software, which is key to harnessing all of the computing power that we build in the layers below it. But really, the key difference between us and what you would call a chip company normally is the layer above it, what's called acceleration libraries over there. We've invented a new form of computing, this accelerated computing that harnesses data parallelism, extreme parallelism inside our computers, so that we can make solutions to computing problems that if they were left to CPUs, we wouldn't be able to solve for another 10, 20 years. We'd have to wait much longer for computers to be fast enough. But to do that, we have to develop very special algorithms that are attuned to this computing architecture. We've been doing that since I joined NVIDIA, about 21 years now. But more recently, we've started moving up the stack. We're building platforms to enable just about anyone who knows how to develop any kind of application to leverage the awesome power of our computing stack. The two platforms that we've developed are NVIDIA AI, NVAI, and NVIDIA Omniverse. I'm largely going to be focusing on Omniverse. That happens to be the thing that I'm building. And on top of that, we have a whole bunch of frameworks that help anyone who's interested in building these advanced applications but don't have billions of dollars to invest in all the layers below, to just take what we've done and build on top of it. All right, looks like it takes a few seconds for the slides to change. So many of you have heard the term digitizing, or maybe not. I think a lot of you here are young enough so that you don't really remember a world where everything wasn't digital. All of the documents and communications and the way we deal with each other today is in digital form. We've digitized these things. We do our banking, we do our correspondence, contracts, all of that sort of stuff in digital form. That's digitization. That's taking analog stuff like paper and turning it into a digital form. What's starting to happen now is another level of this called digitalization. They sound similar, but they're a very different concept. For all companies, for all industries other than the pure tech computing industry, the creation of the internet, the creation of these computers have helped them, but they haven't greatly changed how they actually design, build, and operate their businesses. We have added things like email and web systems and forms and SAP and stuff to companies that do manufacturing and build things. But fundamentally, how we build cars today, how we build buildings, how we build bridges, they're not that different than they were before the internet. Not that different than they were before computers. The reason for that is that it's very hard to take the core things that most businesses do, which happen to be in the real world around us, and turn that into software, turn it into something that software can manipulate. The companies that can do that happen to be software companies or services companies in the tech sector. If you're a social media company, if you're a software company, the very nature of your product is already digital, so you have everything in digital form to begin with, and you can move at the speed of software. You can be very agile. Technology in this space moves so much faster than all of the other traditional industries. So the dream is to take this superpower that the tech industry has, that the software industry has, and apply it to every other industry. If we can turn the real world and the things that all companies do in the real world into a form that fits inside a computer, then all of the benefits we have from software, every industry will gain. So I'm going to tell you a little bit about that. Now, as RP mentioned earlier, this conference is about the metaverse. That's our overriding theme here. She did an excellent job of telling us what ChatGPT taught her. And everything she said is very true. The metaverse is about creating virtual worlds and sharing them so that multiple people can interact and socialize with each other inside these worlds. However, there's a broader way to look at the metaverse. Largely what we've been talking about in terms of the metaverse has been how it applies to socializing, how it applies to entertainment with video games and these kinds of experiences. These are very important and very big sectors, but by no means is the metaverse limited to that. We can use the metaverse for much more. We look at the metaverse as essentially the next generation of the internet. I'm old enough to remember, and fortunate enough when I was young, to be on the internet well before the World Wide Web existed, before most of you were born in this room. Back then, the interface to the internet was only text. It was very, very slow. You could just type some stuff in a prompt. It was still amazing because I could be connected to all of these brilliant minds anywhere in the world instantaneously, but it was limited to just a small number of us. Only people who really understood how to speak the language of the computer and deal with this kind of very arcane interface could access it. All of that changed in 1993 when the World Wide Web was born, when we changed the interface into something that was more accessible to the average person who knew how to use a graphical interface. We created the web and the web browser and HTML so that we could describe all the information on the internet and interconnect it with pictures, with text, with multimedia, and eventually with video and all of the other things we added to it. We see the metaverse as essentially an extension of this. It's the next generation. We went from text to images and video to now having a 3D incarnation of the internet. This incarnation of the internet is actually going to look and feel much like the real world around us. It'll be much more natural for people to interact with each other in this environment because we've had millions of years of evolution to hone our senses and our way of dealing with the world inside that kind of environment. Now, what can you do with this? Well, we use the internet for many things. A lot of it is socializing and entertainment, but it's not limited to that. We use the internet to do work. We use the internet to build things. We use the internet to share our designs and communicate information about our projects and so on and so forth. The same will happen with the metaverse because the metaverse is the internet. And we're going to leverage the unique capabilities inside this 3D world to bring the real world into the virtual, into the software. Now, what does that mean exactly? Bringing the real world into the computer, making it software defined. Essentially, anything that we understand well enough in the world, if we understand the physics, the rules of the world around us well enough, we have the potential of being able to describe that inside a computer with an algorithm. We can create a simulation of that thing. We can take products that we build. It could be something like this microphone in my hand, or maybe a bicycle, a car, a building, a factory, a molecule, Anything you can describe in the real world, if we know the rules well enough for how the physics interact with, how that object interacts in the physical world, we can potentially simulate it. This is what we're building right now. We're building the special computers and these systems to be able to take virtually anything that you can find in the world, bring it into the virtual. Once it's there, once we have it in the virtual world, you have all of the capabilities we take for granted when we're building software. Today, modern best practices for software development is to use continuous integration, continuous deployment. Every time one of my engineers, in the 1,000 or so engineers, checks in one line of code into our software code base, that engineer doesn't really understand what the potential ramifications of that one line change is going to be, because the system is too complex. Many things can break without them knowing. So the way we solve for that is when they check in that code, a whole bunch of computers somewhere spin up and they do simulations of how a user might use that software. And if we find that there's a problem, the engineer is told, this code can't be checked in because you broke something. Your design is not good. If we can do simulation of our factories, of our cars, of all of the things that we design in this way, we gain that same superpower. The thousands of factory planners that work at BMW, one of our partners, when they are making a design change, they can potentially find out that their change was going to cause harm, put a human in danger, maybe make a robot not work correctly, and fix it long before they actually start building it in the real world, where it's very expensive or potentially dangerous physically to do such a thing. Now, what do we need to do these kinds of simulations to build this kind of metaverse? It all starts first with data. Before you can even apply the rules of physics, of how the world actually operates, you need to have a model of the world itself. You see these kinds of models all the time in video games. If you look at a modern 3D video game today, it's essentially a virtual world. It's some representation of the world that has rules in there. There's physics, how things look inside that world. There's rules related to that. For the really advanced ones, many of them start looking pretty realistic. They look like our real world. Some of them look more fantastical. For doing what we're talking about here, to build an industrial metaverse, to build digital twins of the real things, we can't just have game style worlds. We can't cheat on the physics. Things have to behave exactly how they would in the real world. They have to look to a sensor exactly how they would look in the real world. And to do that, we have to first describe all of the things inside this world with physically correct parameters. We need to describe something like this microphone with the exact materials that it's built out of and understand how light interacts with it, how sound interacts with it, how Newtonian physics interacts with it. So we are first building this standards layer. In some way, it's the equivalent to the web, the two-dimensional web. Before we could actually have a web and the internet, we needed a standard for describing all of the things inside it. And that's HTML, hypertext markup language, which we all take for granted. But in its very inception, it was extremely primitive. It took something like 15 years to go from HTML1 to HTML5, where you could do some interesting things like play videos and have an interactive application like Gmail or Google Maps possible in there. So that's what we're building right now, and I'll talk about that in a little bit. We have to build very special computers. They need to be accelerated computers, not the standard ones that you can run Excel on or TikTok or whatever basic things. We need computers that can do these simulations, and they need to run everywhere. Some of these computers are going to be embedded inside our devices. They'll be embedded inside robots. They'll be embedded inside cars. Some of them are standard computers, like the PCs and laptops and stuff that everybody uses today. But most of them are going to be in the cloud. Most of this computation is so big and so difficult to do that we have no chance of running them on small computers that run on batteries. They have to run these simulations somewhere distant. And these applications are going to harness all of that compute, both at the edge and the compute together. So we're building the full computing stack from the edge all the way to the data center to help solve this problem. We need highly specialized skills, and this is what I implore the fine young women that are here today to start learning. We need to have skills in building three-dimensional worlds. How do you describe them? How do you design them? Today, there's a small number of people in the world that really know how to do this well. Largely, they've been in entertainment. They're either in visual effects, companies like Industrial Light and Magic, Weta, Sony ImageWorks, Pixar, these types of places, or they're at video game companies like Epic Games or Roblox. We need essentially everyone in the world to have the capability of constructing these virtual worlds. It can't be limited to just a small number if it's going to become a 3D internet, a 3D web. If you can imagine, if the web was only limited to the same small number of people, it wouldn't be what it is today. We need everybody to become a creator. And the key to that is going to be generative AI. So all of you know about ChatGPT and the stuff that we're doing with text. That is the foundation for where we're going to go with building full virtual worlds. Before you can start talking about worlds, you have to have the abstract concepts of language codified. We're in the process right now of taking these advanced capabilities and understanding and knowledge and applying it to space, to the space around us. We need generative AI to let the average person leapfrog, jump past the skill levels they would need to construct these virtual worlds. Not everybody can go study how to make a digital human like the ones you would see inside the movies that ILM or Weta does for 20, 30 years. These AIs are going to essentially be our assistants that will create them for us. So a beautiful thing is going to start happening, I believe, where we will use AIs to help us create these virtual worlds, and then we're going to use these virtual worlds to help us create AIs. These AIs are going to be using the virtual worlds as their playgrounds, their sandbox to learn how to see, to learn how to behave. All right, so this leads us to my baby, Omniverse. Been working on this for a while with thousands of other people at NVIDIA, all contributing their amazing work, their research, and great potential. Omniverse is our platform for one, aggregating and building these virtual worlds that are physically accurate, and two, for building applications that can run simulations on these virtual worlds. We're applying them currently to a variety of industrial applications, but essentially the platform doesn't dictate what you can use this for. It could be used for any application you can think of where you need a piece of the real world inside the computer so you can run it as software. We provide many foundation applications, ones for simulating autonomous vehicles, for simulating robotics, for building virtual worlds for design purposes, for architecture, engineering, and construction. But the idea is that we're not providing the final solution. We just provide a foundation, a basis that others can take and build on top of to go specialize into their domains. Our job isn't to go create the solution for every industry. We're not a big enough company to do that. We don't have enough people. But we can solve a lot of the hard problems on the computation stack for you. And then you can take your expertise in the particular area of interest and go specialize it. Is there time check? I don't know. There's no timer up here. I can talk for hours like this and bore you all to death. Just want to make sure that I'm not stepping over. Okay. Well, I'll just keep going until somebody tells me to stop. So, We built Omniverse as a stack itself, much like how we've built NVIDIA. It leverages all of the things that we've been building for 30 years at NVIDIA. As you can see, we have the 3 stages of NVIDIA, the 3 versions of NVIDIA already encoded in there. There's rendering for the computer graphics in the early stages of NVIDIA. We still continue to advance. Simulation, physical simulation, and artificial intelligence. We harness all of this technology that we've been investing in, billions and billions of dollars of technology that we create every year, and we bind it into this one platform that makes it easy for anyone who wants to build such an application to do so without having all of that expertise or all those resources. So the darker green part up there is the part that you could fill in yourself. You can extend Omniverse easily by writing code in multiple languages. We tend to prefer Python because that's the one that's becoming the lingua franca for AI in general, and I think many of you here probably have been studying that. But of course you can do it in C++ and CUDA and other languages as well. But we work really hard to make it as easy and accessible as possible for these higher level languages. And I think we're not too far from the point where our programming language just becomes natural language. We'll soon be programming in Armenian. You just say words in Armenian and the computer understands what you're saying and it generates the right code for you. Essentially an extremely advanced compiler that can take your intentions and convert it into a program. This is my dream. This means that I will never again have to help my mother with her IT problems because some AI will do that for me. I mentioned earlier that we need to have a standard way of describing virtual worlds. We need the HTML equivalent for 3-dimensional data. We found this, we found the foundation of such a model many years ago. In 2015, Pixar, the same studio that invented much of our early computer graphics, Toy Story, Nemo, all the movies many of you know and love, they open sourced a toolkit, a system for not only describing virtual worlds, but composing them, a kind of engine to put these virtual worlds together. And it kind of made sense that Pixar would be the one to do this, because there's no company on earth that has been doing computer graphics, building large virtual worlds, combining data and designs that come from many different disciplines, from people who know how to build worlds with vegetation, to digital humans, to cars and whatnot, and combining them all together. Nobody's been doing this for as long as Pixar. So over 30 years, they essentially converged on a really elegant way of describing such virtual worlds, but leaving it open so that it can be extended. So you can add new types of descriptions to the things inside this world. So we saw they did this with USD and said, this feels like how HTML felt in the early days. It wasn't complete, but it had a foundation that you could build on top of to get it to where we need to go. So we've been investing for many years in extending USD and turning it into something that can become a standard, connecting it to all the other tools that are out there. Next month, there's going to be a large conference. 1 minute, okay. I'm going to skip past this. With Omniverse, we have connections to hundreds and hundreds of different tools from very different ecosystems and domains. So you can bind all of this data together. I urge you to check it out. It's freely available for you to download. You can run it on your PC with an NVIDIA card. There are already many developers that are developing applications that they are selling themselves, built on top of Omniverse. And we also have many customers in many different fields who are using it to do simulations of things like their factories, the cars that they're building. Here's a few of them. I'm going to play a video right now that shows some of these examples. Short video. Unfortunately, the video playback is a little choppy. Trust me, it's very smooth. So here's an application that Heavy AI has created to simulate 5G towers to optimize placement of them in cities. Here's an example of Lowe's, a big store, a retail store for hardware goods, simulating building their stores and placing things inside the store. WPP, the world's largest marketing agency, simulating digital twins of the products that they're selling. Amazon Robotics uses Omniverse to simulate their warehouses and all the robots inside them, to program them and set them up so that they can be as efficient as possible. Ericsson also doing 5G simulation. Siemens Energy and Siemens doing simulations of their energy systems and factories. Fraunhofer building these AMR robots. We can teach robots how to behave, how to walk, how to roll inside these worlds, and then bring their brains out into the real world. All right, Sashka, you told me 1 minute, but can I just have 1 more minute? Because I want to talk about women, if that's okay. I know it's a little bit weird. I'm a dude standing up here at a Women in Technology conference. First, I'd like to give a shout out to some of the amazing women that are on the Omniverse team. We have amazing engineers, researchers, and technologists in general on our team. But we don't have enough. We always need more. I don't know why, for reasons that I still don't quite comprehend. My beloved field of computer graphics, which is a subset of computer science, tends to not have many women in it. And I would think that it should be the opposite, since it's the intersection of art and creativity and computer science. Something we did wrong early on seemed to chase them away, but we're starting to get more women in this field around the world. The other thing I'd like to point out is it's extremely important that everyone here have an education, at least some education, in how the technology works. I recommend you understand some computer science and computer engineering, AI, but not everybody has to become a programmer. Not everybody has to become a researcher. We need product managers. We need product marketing managers. When I was young and foolish, as a programmer myself, I thought all of that stuff was worthless. Now that I'm old and wise, I've realized that there's absolutely no way I can be successful unless I have amazing people like some of the people up here on my team who are helping me communicate to the world why what we're building is important, why it's valuable, who it should be targeted at, how we should build this thing so that it can be useful. These are the jobs for product managers and product marketing managers. And I think in Armenia, we still don't quite have a discipline of this in general, not just women, but in general, the understanding of product management and product marketing is still pretty nascent here. So it'd be great to see a pipeline of people trained in technology moving into these areas and learning from best practices outside in the US and elsewhere. And I believe that can happen. And at NVIDIA, we, like most other tech companies, and maybe in some ways even worse, have a real problem with diversity, especially with women on the technology side, on the engineering side of our business, which is the majority of it. We just haven't had a pipeline like we needed. But we've been doing everything we can for years now to make NVIDIA a great place to work for women and to attract them. And we participate in events like this. We try to provide every benefit to make it easy for women to come join us. And we want to also put women like the great women I showed earlier out in front so that all of you can see that it's not just old dudes like me, but there's actually other women here that could support you, and ones you can look up to as role models to join us. Yeah, so we have all of these things available. We have learning developments and mentorships. We have many benefits for working mothers, and please come check us out at our booth over here. We have some great women from NVIDIA who will tell you about what it's like to work at NVIDIA. We want to build up our team here in Armenia with enough women so that we can turn this office into the first one where we have 50% female engineers. That's at least our dream. And I believe that in Armenia this is possible, because when I do go see the boot camps and Tumo and all of the other amazing feeder places, there's 50% or more women that are part of this, 50% or more girls. There's no reason why our office can't be the same here. So please apply, please come check out our internships, and I hope to see you later. Thank you.